So this is the exciting second part, and this is why this is a difficult arc problem, okay? So he hits the ball at a speed of 41.3 at an angle or whatever, right? Assume the ground is level, ignore air friction, and then now it's these ones, right? So suppose there had been a wall 60 meters away from the launch site. At what time will the ball hit the wall? What height will it hit the wall? What is the velocity of impact? Oh my gosh, right? So the good news is we can use some of the stuff we've already done before. Right, so we're going to use these components, the 8.446 and the 40.427. We'll just use those in here.
Let's fill it in, baby.
So 8.446 and 40.427, because it's the same launch. It's the same golf ball stroke, I guess is what we say, right? And then let's draw a picture of what's going on here. Now it's leaving the ground, okay, like this. And it's going to fly through the air, and there's a very tall wall 60 meters away. And it's going to go and strike that ball. Now I sort of know that it's going to go 69.7 meters, right?
Yeah,
so
that's what we figured out last problem, right? Like we figured out that it's 69.7 meters away. That's why Mr. Murray drew the wall over here. Because we already knew it was going to hit it on the way down.
It's going to hit it on the way down there, right? And so that 60 meters that the wall is away, that's a horizontal distance. So I'm going to put that in here as our horizontal x. Okay? And then it's always true that this is 0, that this is negative 9.8. That these guys are the same, because if the acceleration is 0, then they can't change, right?
Now, can we use the same time from this problem that was 8.25?
Kids always want to.
They want to, but they
that's
can't.
The whole time it's in the air.
That's the time that it lands here. It's going to hit here. So we're going to get a time that's less than 8.25, right?
If we go on more than that, we'll know we're wrong.
Yeah. And so, but don't we have enough to figure that out right now?
Yeah, we actually, in this one, it's weird because we're actually going to be able to figure out this side, and then it's going to go that way.
Right.
So
we get x is average velocity times time.
Distance divided by velocity is time, right? It's all you do on this side literally is x, v, and t. And so if you want t, you just cover up the t, x divided by v. So 60 divided by 8.446.
Please be less than 8.25.
7.104.
And it is, just like we predicted. And
if you're tuning in late, these numbers here are from the previous part. So watch the video before. This is 41.3, right? Cos 78.2, and this guy's 41.3 sine 78.2.
Right.
That's where those are coming from.
Now we got time on both sides.
Time comes across.
Time is on both sides.
Okay, and now we know three things. And we can figure out everything else, and we have to figure everything else out, right?
Yeah, they want us to. So here we go. Why don't we figure out? Well, I don't know. I'm kind of in a crazy mood. Let's figure out VF first.
You want to do VF first?
Yeah.
Okay. I'm gonna put this guy on hold here then. That's the one I picked to find this guy. But let's see. Let's VF. Let's see. Oh, let's use this guy. Let's use VF is VI plus AT. Easy as pie, right?
Yep.
Okay, so let's go 40.427 plus negative 9.8 times time. I should have left more room, Mr. Doug. It's 7.104.
Yeah, it's okay. Cram it in there.
Yeah.
It's enough space.
Okay, so 40.427 plus negative 9.8. Don't forget the negative.
Yeah.
Okay, times 7.104. Negative 29.12.
Now, see, that goes along with what we originally said with it
19.
being on the way down when it hits the wall. So that's a good thing. Now, the equation that Mr. Murray first picked to get the x, yeah, you could use that, but you could also use other ones now too.
Indeed.
But, let's use this one.
Should we use that one?
Write it down.
Okay, that one's kind of a pain now. Let's see. 40.427 times 7.104. Just checking my work here, making sure. Okay. Plus 1/2. Oh my gosh, I really don't have enough room. 1/2 negative 9.8 times 7.104 squared. And everybody forgets to square that guy, right?
Yep.
So I'm just plugging into that. So 40.427 times 7.104 plus 0.5 times negative 9.8 times 7.104 squared. Is that right? That looks right, doesn't it? 39.9 meters. So let's see, at what time will the ball hit the wall? I think 7.10 seconds is the right answer. Okay, at what height will it hit the wall? Well, that's our vertical X. It's still 30, and that's surprising to me that it's still so high. Because remember, it only went 83 meters in the air. Wasn't that right? This guy, right? Our height we figured out to be 83. So it's nearly as high. It's half as high as it was, right? But of course, it's going really fast down. It's going to cover the rest of that lickety-split, right? So it's 39.9 meters up this wall. So my picture's not all that great. It really should be like half the height or something, right? So let's see. What is the velocity and impact of the wall in component notation and angle magnitude? So we can do this, right? Here's our impact velocity, right? So it's just simply 8.446 meters per second in the x direction plus negative, I'll just say negative 29.19 meters per second in the y direction. So that's component notation.
So now we've got to draw our vector. Should we go to the left or right, boys and girls?
To the right.
To the right. And then
down. And down a lot more.
Yeah, a lot more.
Right?
And then we can draw in our resultant vector.
There's the speed, right? This guy's our speed of impact. Right, and then we can
figure out the hippopotamus.
The hippopotamus, here it comes. Okay, so second square root, left, I like to do it all in one swell foop. 8.446 squared plus 29.19 squared.
And the biggest side of the triangle is the one that's called a hippopotamus, and that's easy to remember because it's the biggest side. No, just kidding, it's the hypotenuse. But that's 30.34, and now we want to figure also out the angle. 30.4.
And then the angle
is going to be the inverse tangent of opposite over adjacent. Opposite in this case being 29.19 because it's opposite. Adjacent touching is 8.446. And let's figure out what it is.
Second tan of 29.19 divided by.
Okay. Slow motion instant replay. It was second tan to get to the inverse tangent.
Yes. There we go. So what is that, 73.9 degrees? So if you were going to say an angle magnitude vector, you would say a speed of 30.4 meters per second at 73.9 degrees below horizontal.
Yep. So if we wanted to put that here, this would end up being, as we said, 39.9 meters. And then if we want to put the velocity of the impact, we would say 30.4 meters per second at 73.9 degrees below. I got to pick whether I want it uppercase
He's
or
got
lowercase.
such nice handwriting.
Below x axis.
So on a test, we'll probably ask you to draw a picture of it.
Yep.
Like that, and label the angle that you find. I think there's nothing else left to say.
Nope, except
Code word.
code word is going to be...
We should put the code word in the middle sometime.
Code word in the middle sometime would be good. Code word, Kalen.
Kalen. C-A-E-L-A-N.